How's it going, everyone? Welcome. Eulia Gonzalez here. And let's go to look at the chapter 2, which is serving JavaScript and your knowledge about the language. This is a series of videos of looking and taking notes of the book You Don't Know JS to know what is the truth of JavaScript, not only the history of it, but also the people who oversee the language specifications, those who own the trademark of the language, as well as the intrinsic nature of how this language actually works, right? Which is exactly what we did in previous videos. So a quick recap of those videos, especially for the chapter 1, which is get started. So in today's video, we're going to look at the chapter 2. But just to make a quick recap of the chapter 1 here of what is JavaScript is describing is, well, who made this? Why the naming in itself, which is an artifact of a marketing shenanigans to position the language from a Java audience as a lightweight alternative of this well-known but heavier Java language, right? So also you have to be familiar with the language as well as the concept of scoping variables and functions. This is also that you as a developer must have his experience with the way of how you can write C++ application. All right, but in any case, right, the deal there is that at the end of the day, the idea of recap or looking at who made this and who now owns the trademark of JavaScript, which is Oracle, and what are the group of people that oversee the technical spec known as the TC39, and what this spec is describing. Get yourself familiar with this spec. So pretty much like Java had Java, Go, and Python has their own spec. So few people actually in JavaScript ecosystems know about the existence of the language. Not only that, and those who knows, they barely have read it. And I can tell you that if you're a C programmer or a C# programmer, right? And if I ask how many of you have had to read the spec, I think that a huge decent amount of people actually might raise his hand. But if I ask the same to JavaScript developers, I could barely have one or two hands. So, but the idea of this is understand that all of these nuances, as well as who made this language, what is the language, who owns the trademark, who now are responsible for adding or updating features of the to the language, and this group, which who makes this, which is a series of folks that works in the web industry technologies, whether it is browser makers or device makers. So you can also be part of the discussion, but only those who get in that room when they meet this bi-monthly, hosted by the company, and some of them might receive some sort of compensations to be part of the to be part of the group of the commit. Now this commit, and people like me and you, anybody can participate into these proposals to see which one of them actually makes sense. And ultimately, as I mentioned before, those who get into that room actually are the one who are going to make their proposals or their champions, aka work up to the way up until it finally is approved, accepted by the language. So this is now made of several stage, 5 stage from 0 to 4. And this is something that may take now weeks or months or even years for a champion or a proposal makes all the way up to the top, right? To be accepted as a feature. So not only that, but when we look at the spec in some of those JavaScript implementations, because unlike the TC39, they might not know the entire reality of the web. Some of those JavaScript implementations can and will decide to not stick to that. And there is a particular appendix on this docs that says that describe as well, due to legacy reasons, there are some JavaScript environments that will behave quite different. And this is the behaviors. But overall, and because now the TCC is made of people, they sometimes actually make some errors. A good example was this Mushgate. When they have to, you can also take a look at that. This smoosh gate, right? As you can see here, right? The idea here, there is a very interesting read if you take a look at that. But the thing here is that because this commit sometimes now makes some proposals, and some of them might break the web, which is something that they don't want to. So they have to go back to the drawing table and then now create a new proposal or refine the proposal. So for example, in the case of includes, which is a method for collections, or in the case of the Smushgate, which is the way of how you can flattening all of this, or how you can flat in a recursive way is all of this collection nested, all right? So the name was, so the name have to be renamed as flat, right? Not as flattening. And that was because there was a particular library out there in Germany that makes use of that name. And not only that, that it also is something that do some dumb manipulations. So the thing here is that this is the way of now these proposals are made up to the way to the top to be accepted by as a proposal. So because this mismatch that can happen here between what we think or what the TC39 think and based on its experience and what is the reality of the web, because of this mismatch, is something that is similar to what happened to a lot of JavaScript developers, and I was one of them. So I didn't know how the language worked, and the more your thinking diverge from what the language does, that's when you introduce a box. And this is something that Getify, the creator of this book, actually mentioned, described. And I think that is the source of most of your nights and overnights spending, how the things work, how can we make this, and so on and so forth. So there also are better problems to that, or there are there are problems that are less predictable than that requires way much more attention. So because of that, right? And do the JavaScript implementations that you can now run is in multiple environments, whether it's on the browser, on the server, light bulbs and robots. So despite this collections of environments, the reality that matter is the web. So because also inside of the web, and the TC39 doesn't want to break the web. They follow is this forward compatible, okay, as a way to provide, as a way to guarantee that your applications behave the way it's supposed to, right? Whereas unlike HTML and CSS, which are forward compatible, so your design might break, or a design done in 2005 might not work as expected in 2025, right? So this is also the reason why this thing called polyfill is important, and I know that I need to actually is more than the theory, because it is good and it's great to know about this, but we know we need to actually is dive deep into this, okay, to understand now, for example, is the polyfills and how can we use that, right? Is more likely, is more to, yeah, this is a very interesting yeah, a very interesting question, uh, to see that is a comprehensible list of things that you might want to work, especially question format here, code in your browser, solved by X interviewers, test cases. I think that's something that we're gonna see that, not right now, because I want to have is a more understanding of how the things actually works. All right. So in any case, uh, this is also part of the things that we're going to see that later on. All right. I also would like to sign to this, and then I'll take note out of the most relevant questions for interviews. Okay. And the best agent for real world from the desk as well. So this is what we're going to do, but later on. So in the meantime, okay, in the meantime, as we move on to understand and explore is this polyfill, which is also something that we must actually build. All right, we must actually build this polyfill. There is also another particular website that allows us to do that. So for example, it tells us how to implement that. Let me see if this is polyfill, no. But for example, it tells us how to implement now, implement an observable from event, an interval, and a subject and from, you know, all of this particularly patterns to understand that. Implement string.prototype.trend. Implement your own object.create, and so on and so forth, right? But in any case, this is something that go beyond the scope of today's video. I just want to make a quick recap of the chapter 1, all right? And also, why it's important to, at least for us, to understand what are the different programming approach when it comes to understand the problems and solve that, which is a procedure, which is a collections of statements that they might be called one or several times. You may provide is inputs, and then you may get back is one single output or multiple outputs, right? So we also have is the object programming, where the idea of this is that if your problem is about coordination and communications, then object programming actually facilitate that by encapsulating the data and its logic into one single bundle. Then we also have is for computations, or when when the problem is about computations and calculations, how functional programming is makes much more sense to do this, because now you have to follow a strict set of mathematical principles that you must abide by, uh, to actually get a deterministic behavior. So this is known as referential transparency, which is a fancy way to say that by the time that I call these functions, the entire program cannot and will not uh, change in an unexpected way or even break. So mention these particular procedures and also to understand how the JavaScript language works, whether this is an interpreter or if it's a compiled language, uh, because there is a history in the history of programming, looking at the programming languages, the interpreted language has been seen as disdain, all right, because they are not optimized or fast as their compile partners. However, the discussion here is not about if this JavaScript is a language compile or optimize or interpreted. The heart of this is that how the language is processing errors. And I think this now new vision, which is something that Kyle actually mentioned, is it makes quite a lot of sense. Because now, unlike compile language, where it's going to analyze the entire program, okay, for any errors, and throw any errors at compile time, at build time, before it is executed, all right. So once it parses that, so there are several steps in the compiler theory. There are several steps that happen here, which one of them is the tokenization, which is whatever your code looks like, whatever this set of instructions look like in this language, is going to be transformed into tokens, into things that can be understood by the language. And all of these tokens are going to put in some sort of buckets here. So you can think of this token like when you're trying to identify things in a dictionary, right? So for example, you identify, hey, this is a character. Hey, this is an alphabetic character. Hey, this is a character that I recognize, because if you're reading Chinese, you're gonna throw an error. Unless you know Mandarin. And if you do, please let me know because I want to learn that. But in any case, so if you are able to recognize this token, is this character, is this word, is this keyword, is this statement, is this expression, is this operators, right? So plus or minus or multiplications and divisions. So if you're able to understand them, right? It turns out that it's going to be now passing through the tokenization phase, known as syntactic analysis, and then it's going to parse that to create now this abstract syntax tree, which is a map of how now the language identifies what is the structure of all of this structure of all of this statement that you provide, all right. And then usually after that is generating now a binary representation of the code as an executable that is ready to be distributed on that distro that was compiled. So for example, this whether it is Windows, whether it is any of the distro of the Linux distro, or iOS or Android or Android or iPad, you know, you name it, any of this, that's exactly what is doing a compiled language. However, in contrast with an interpreted language, when it comes to analyze an error, a truly interpreted language, it will have to now, for example, you have 5 lines of code. It will have to go it will have to go each one of them until find the line 5, and let's say it throw a syntax error. Hey, I cannot recognize this token or this character, or there was an expression here that I recognize, so on and so forth. So Of course, this is quite slow, but JavaScript doesn't work that way. And the way how you can check that is by actually is making a syntax error. So I'm not gonna do that. But I think that that's very interesting to understand that when it throws you a syntax errors, because when you putting now console log before that error, all right, if this is a truly interpreted language, it will evaluate all of that, right? But the thing here is that JavaScript doesn't work that way. In fact, the way it works is that when your JavaScript file leave the ID, it will now be transpiled, which is a fancy way to say that it's going to be translated into a high level language. In other words, a version of the JavaScript that is widely available for all the browsers out there, all right, and then pass through a build process, okay, where it may perform some optimization techniques like code splitting or minification, so on and so forth, where is now ready to be delivered. So when the JavaScript interpreter, for example, in the browser, actually make an HTTP call and it get that file, all right. So the browser now, once it or when you make this network request, you get that JavaScript file, all right, via HTTP, the hypertext transfer protocol that allows you to now is using is a particular verb to get that data out of that. For example, using a get to get the data, and sending is the header as well, or using a post or a post to send data, a put to update data, a delete, well, to send now a verb to delete some resource, or the patch, or the options as well, which is something that is pre-flight before you is pre-flight on any request. This is using, for example, as to detect some course. Okay. So in any case, once you get that, your file now uh, is parsed by the JavaScript engine. It goes to parse that and convert it to an abstract syntax tree. That abstract syntax tree generate is an intermediate representation of the binary code, which is bytecode. And this code plus the internal compiler and the profiler, which actually constantly checking for doing some optimization until the entire code is ready to be executed, then is when that happens. So the thing here is that JavaScript, in essence, if not in practice, it is a compile language. So because there is a concern of this process of parsing and the execution and how fast it can be done, there has been quite attempts to do that. So for example, the ASM.js, which was developed by Mozilla engineers back in 2013, to demonstrate that JavaScript is not that slow as a lot of people might think. They poured a new Real 3 game into the browser, right? So this was a subset of JavaScript where now send some hints to the JavaScript engine to do further optimization. This code was not meant to be authored by the developers. But years later passed, and then now the attempts to make the language much more faster, or bring the language in a faster execution and parsing and execution. So was is this spiritual successor of that idea, where now they want to keep that when one is to avoid is a particular stage called as the parsing. So this stage by representing is the code as an assembly-like language, where you are going to use this language as a compiler target, since now you don't have any parsing phase. It is now this representation uh, of the assembly like, which is almost close to the machine, where the point of this is now that we can is use WASP as a compiler, as universal compiler target that can be run in a particular WASP environment. So no matter which language you have written that particular instruction, and I think that's quite very useful and powerful. But it is about to the owners of those programs, yada yada yada. So for example, that it would be very very powerful for COBOL to do that. Again, that's something that I cannot control. For example, anything related to the pension system, that kind of stuff, or the retirement system. So, but in any case, is this the stage, okay, that now WASP has become this universal target compiler? So again, if you're reading your code in C, C++, in Rust, yada yada yada, now you can actually pour that into this WASP that can be ready to be executed by the WASP environment. And I think that's powerful and mind blowing. Another thing that is important to understand is the strict mode, the strictness of JavaScript, which is a set of rules that promotes that. So it's a set of rules that developers must follow to get the most, or to provide now hints to the language or to the engines to do even further parsing and execution of your code, right? So the entire reason of using a string, which is this particularly primitive that now we can see in React, like use client or use server, but this was something that was previous to that, and this is something that perhaps you might not be well aware of that thing that it exists, but when you are transpiling your code, this is something that's happening behind the scenes. So this user strict is just a set of practice, and it's just a set of practice, and it changes the semantic of how now the JavaScript engines will is process. It will be is parse and process some of your instructions for further optimizations, right? So some of this are, for example, is some of them might be silly, all right? So for example, is that hey, when you have a function, your name parameter must be different, all right? They not might be the same, right? That's a good one. The other is that when you want to have access to the window or to the this object inside of a function, the value by default won't be is a window. In fact, it will be null, right? And then some other uses strict. For example, so use strict. For example, you say, hey, function, let's say, yeah, I was gonna put it here. Let's say console log dot this, right? Exactly. You are right, because it must be like this. Function statement require function. Function. My bad. I didn't read that. yeah, let's gonna call this, function, and then right after that I want to call this function, and now it's going to execute that, right? So if we don't put now, for example, is the strict mode like this, right? It will now give you is the window objects. And this is just to describe some of the behaviors that happen, as well as the hosting and so on and so forth. But the idea of this is to prevent this kind of stuff. Uh, so, uh, well, now where once we are serving JavaScript is to understand is what is this program is, what is a program in JavaScript, or how do we or how now JavaScript treat programs, and it treat that per file, which is a counterintuition, because we might think that when JavaScript is loading all of these different files, all of them now are part of a single program, and that is not true of what happened. Only if each one of those standalone programs, and the explanation here is that you may wonder why and how do you know about that. So for example is you have now several script tags, and inside of those tags you somehow is import is, let's say, Google Analytics, all right, which is not a critical one, but what happened is that if one of those script, particularly in our case, Google Analytics fail, at best your application will operate partially, right? And this is one of the problems with all compiles, with run with dynamic language versus the compile language, all right? But also yet it is full power and capability. So the only way of a program or JavaScript see several of these standalone files as one single program is when they now share the state via the global state, all right? Or if they now expose the public methods or data in a model. And speaking of models, so for example in EX6, where we have now import or script type models, the idea is that each one of those models will behave the same, all right, as a standalone models, but at runtime they will now is be interoperables among them, which may act or which act as a single program. But again, for example, it is useful to think that our programs are not going to be executed uh, file by file. This is how now JavaScript see the files. But this is great because once we go further in the language, especially to look at the values and how how the values are, especially is what a value is, uh, where values is the most important unit of information, and this unit of informations are defined by the language in itself. I'm gonna make a quick pause here because the name of claw, so claw as the, for those who are not aware, well, claw actually comes from the name of Shannon Claw, a mathematical, it's a North American mathematical in computer science that actually create a paper of the theory of the mathematical theory of information, and that's mind blowing because it's like to quantify information. And if you're not aware of the impact of this, it's like how do you it's like trying to quantify is your feelings, for example, no, is trying to quantify is abstract stuff here. Information is an abstract stuff. So how do you quantify that? How do you quantify your thoughts? All right. Which one of them are more heavy than another one? All right. Which one of them are more useful than another one? Which one of those programs are more useful than another one? And that is mind bending stuff, bro. That also is a combination between the mathematical, the hard science, as well as the psychology or the soft science. Uh, but the beauty of this is that we can find or Claude actually find a mathematical definitions of quantifying information. So I leave you that so you can trip that out. In any case, you're not here to hear me trip about that. So this information, all right, where is this most important unit of execution? Is most important unit of information that programs use to maintain the state. And when we want to maintain the state, we have different ways of how can we do that. Whether it's we want to maintain the state as a string, hey, I want to represent this different character, whether it is a alphanumeric uh, or whether it is Latin based or Persian like or Arabic language or hand based, which is the Asian style of writing. Okay, you have Korean, Japanese, Vietnamese, Cambodian, Chinese, Philippines. You know, that's mind blowing. Okay, and well, uh, how how can we represent each one of those elements as a string? Okay. Also, how can we represent these numbers? All right. What is the representation that is using? In the case of a string, is using Unicode, which uh, is a format to universally transform the code, or using Unicode, which is, hey, this piece of code, this sequence will represent now a character, right? Similar for the numbers. Hey, this sequence that follow is a specific spec, IEEE 754. This sequence, in this case, is using a 64. That represent is numbers here, and because of this representation that is large enough, it has some restrictions. So you have, for example, now 0.1, why 0.1, 0.2 is problematic here, because it doesn't actually give you the precise value. And this is one of the problems that it has when you're using is any of this language that use that representation, which is a standard. Okay, the Institute of Electrotechnical electrotechnical engineers, which is IEEE. The Institute of Electrical and Electronic Engineers, right? So, in any case, so we're talking about these representations. Also, is the Boolean, which is true or false, just like that. It's a keyword reserved. We also have a symbol, which is when you want to represent values that you don't want to expose, and then we're not be able to get that value. You're not gonna see that. You can use that, for example, in low libraries or frameworks, uh, as well as the kind of emptiness, such as null and undefined, and why we use, for example, prefer undefined rather than null, and that is for historical reasons, because when do we want to determine the value of each one of those? Well, exactly, when we want to determine the value, so now there is a funny behavior with null. In any case, also another type values is the big int. When the integer representation is not enough, is not accurate, all right, we want us to use now big int, which is useful for financial applications and gaming. So the last but not least is now the objects. And for example, in object we have now an array, which is a special type of objects that it is an indexed, it is a numerically indexed collections of values, even objects and arrays and functions. Okay, and we also in the object itself is now a key, is a hash table, right? Is a key value that is structured here, where now functions, okay, are a special type of objects and also is a value. And this is quite useful to understand because once you know that the value of something, when you want to determine the value of something, all right, using the type of, okay, when you want to determine is the value of something using the type of, for example, for the primitive, you also get everything. So for example, for a string, okay, you can say it's, for example, string, or a number, right, or a boolean, right, or a even undefined, as you can see here, undefined, right? But when we come to null, you have now these things called objects. And when we put now here an object, we get an object. And when we put now an array, we get now an object. And when we put now here a function, for example, it actually gives us a function. And this is extremely important to understand because now you can see what are the values that are determined by the language, all right? And this determination or this label of values are quite useful and quite important to actually is exploring is the functional approach, which is something that we're going to use in React applications, in Redux, in React Native, and all of this, particularly field of writing is user interface. So far so good, right? Because once we explore about how you can is using a value, right, whether it is explicitly as a literal like this, right, or you can also is held the value in a variable. A variable act as a container, and this container has a special form, syntax form that is has inherent behaviors. So this kind of behaviors that we're talking about is, for example, is var, let, and cons, and how now var and let, for example, where now let is much more constrained of how this container is going to widespread to the program, where you have now is the where you have now is the this value as a container. So var is now global or functional scope, okay, whereas now a let is a more constrained version of the var, which is only inside of a block scope, right? And it cannot be redeclared. And cons is an even further, uh, yeah, and cons is an even further constraint variable declarations, uh, where now it not only works per block scope, but also it cannot be redeclared or redefined, right? So there is also a very specific nuance here. So stick to use cons with primitive, because you're gonna get if that intuitive behavior. Because when you use now cons with objects, which is something that you can redefine, good, or reassign, great, but you can mutate. And this is when this particular confusion comes with this. So in any case, we were now finally is looking at how this variables actually behaves and works. So especially when you have now a function inside of this, all right? And when we talk about this, so a way to actually explore that that this is true, that counts are actually block scoping, we can say is this. So if if false, right? So if false, comma, if false, I want to have this and say, hey, my name. All right, and then I want to console log is this, right? My name. And then I want to is console log that, right? So it is interesting. It is interesting. Another interesting thing is if we do this, so it will happen that it will evaluate this, it will get into this, and then throw this particular error. So this error happened is at runtime, and as it is, right? So, so now the language in itself is demystifying. It's actually where you understand now how that things work, pretty much, right? So that's great, all right, because now another way of how you can declare variables is in functions. So for example, the identifier, which is the name of the function, and the parameters, the identifier act as a local, act as a global variable, all right, whereas those parameters act as a local variable inside of the, exactly, inside of the, yeah, act as a local variable inside of the, yeah, act as a local variable. So yeah, so they act as a local variable here. So why am I, and the other is the error clause in the try and catch error. So why am I mentioning this? So when we look now at the functions, so because so far we have this describing is the way how the program works in JavaScript, as well as the way how the program works, what is a value in JavaScript, what are the different type of values, how can we determine the value of each one of them, and understand that functions is a type of values that when we are able to describe and using variables, uh, whether it's with var, let, and constant, knowing it is uh, constrained, uh, we also look that since a function is a value and can be used as a value, so the term here in JavaScript is spread, because you can use this as procedures, as I mentioned before, uh, and as function, which is as a mathematical, it's a mathematical rigorous set of rules that functions must set abide, especially if you're using it as a functional programming. So why am I mentioning this? Because when you define as a function, and uh, yeah, when you define a function using the function's definitions, or which this association between the identifier and the body of the function, or the value of the functions, happens at compile time. That's interesting, okay? Whereas the function execution, which is, this is kind of the things that, for example, you do something like this, right? So you define here some function declaration, right? Function declaration here. You say, hey, so I'm a am a function declaration, and I need to use this double quote here for this. So I'm describing as a string literal, all right, value, all right, and then I'm going to define here a var using function expression, which is when you assign to a variable a function like this. Let me actually copy this, say this, right? And say this one, right? So I'm a function expression, all right? The association between the identifier and the value happens at compile time or parse time, where this happen is at execution time. The association of this happens at execution time when that statement is evaluated. So this is huge and this is important, right? Because since functions can act now as a token, all right, this set of instructions can act as a token. We can also is use this as a way to pass that when we need to, this set of instructions, okay, or to receive that when do we need that, and that makes this not only quite powerful but enable this, for example, is functional programming practices like the composition. So when you have now a function here, and this function, for example, now is the common example here is now sum. All right, right. You have now a set one. You can say function here, and then you say something like this, right? You can now define is a set of instructions that is going to be used. You can also is unlock things like high order function, which say, hey, instead of defining is this as it is, all right, I would like to say, hey, this function called sum, all right, that I'm defining is it is behavior, and I can is return one single value or multiple as an array, or as an object, or even a function. This is when it's now unlocking is this particularly functional patterns here. So you can say, hey, I want to now get the sum of 2, all right, and then do something like this, call sum, where you can fix one value and then expect another one, right? And then you now later on declare now a token, all right, with a container to say sum 10, right? Or you just call is let's say total, right? And then you say sum 2, this will not work because you actually need to provide is something like that. So as a way to make the things work, right, you can is now rename or reshape the shape of this function. How so? By saying something like this. You say, hey, I want to receive is the sum here, and then I want to now expect another function here that I want you to return is once I get all of that, right? Once I get all of those values, okay, now I can get this. And here what we did is just a manual currying, which is a fancy way to transform a function's arguments into a series of functions that takes one argument, unity functions. And I think this is quite interesting, very important to know, because all of this, what is unlocked is, hey, I want to preset something here, all right? And then when I need to get that, all right. So what you're doing with, which is one of the powerful things, and I know this go beyond the scope of today's video, but one of the powerful things that this particular pattern is unlocking is that you can now generalize things to get specific use cases for that. So this is the particular use case for this. And I find out very, 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 very powerful. So for example, here by calling it sum 2, and then you say, hey, I want to now get the total of this, and please print that out. You get is sum, or you get is a total, right? That you get now is that value. So this is not just a simple mind-bending or interesting things to do. Rise, Megatron, rise. So yeah, so this is not a single trivia to follow and stuff like that. You know, this is not some interesting stuff to know about. No, this is useful, and this is useful because now you are defining some general tools that you want as general instructions, all right, that you want to go with, all right. In those general instructions, there is a particular library out there that allows us to do that. For example, Lodash, to work with these collections of values, all right. I think is exactly, it's a utility language here, right? It's a utility language that allows us to use some of these functional programming patterns where are useful to handle this in the most efficient and effective way possible is large collection of values. So for example, when you want us to compute something, when you want to do some transformations, functional programming help you to do this, especially in large data sets. So that's very interesting here. So for example, in the documentation we have we can is now is work with the array, right? Compact, concat, different by, fill, find index, flattening, okay? Which is all of these are things that we have now. Some of them, not all of them. We have now in building in the language. For example, for arrays, and then we have now collections. Hey, I want you to come by each one of those elements that is here. And the other is, hey, for each one of those elements, I want to apply some sort of transformation, right? So count by or every, for every element I want to apply this flat map for each. Group by, hey, I want you to group me this for something, okay? Key by, reduce, hey, I want to now is produce a new data structure from this, okay? Given this collections, I want to walk through this and then compose is a new one, okay? Then you have for dates, for function, which is something that we are going to look at this. I am not that quite aware of this. And then you have now for the language, is like, which is very narrow specific to the language. Hey, I want to clone a value in a class. So, and also for the math and objects. So, but the thing here is, as well for sequence, something that we don't have built in the language, but we can treat as it is. Okay. Hey, I have this sequence of data, I have this sequence of objects here that I want to sort them by something, and so on and so forth. Similar to a string, but now things are starting to make a lot of sense because we are understanding is the problem. And once you understand that, is this is it, man. This is it. This is it. So, all right. We are just taking notes out of this. We also describing is how you can actually use functions to return values or not. And since values can be now used, I don't think I put it this exactly. And since functions are values in JavaScript, something that is not true for all language, all right? And those who treat functions as values, now they can benefit from the functional programming. Since functions are values in JavaScript, we can use this to use that as dynamic programming. I think it is the name. Okay. So in any case, we can use that as dynamic programming. Dynamic programming. And this is the mathematical explanation of this. So in any case, it's something that we're gonna see that later on, but not right now. But since functions are values in JavaScript, we can use it to understand. We can use it. We can use it in object in we can use it in since functions are value in JavaScript, we can use it in objects. We can use it in objects. So we can use it in objects like this, right? So not only that you can define is a variable that holds a object where these key values are functions, which is enable this dynamic programming. Interesting. Hey, by the time, okay. So in any case, in this snippet, reference to the three functions greeting, questions, and answers are included in the object held by what to say. Each function can be called by accessing the property to retrieve the function reference value. Compare this straightforward style of defining functions on an object to the more sophisticated class. Okay, compare this straightforward style of defining functions on an object to the most sophisticated class syntax discussed later in this chapter. But this actually looks like so this actually looks like holy. So as you can see, this actually looks like the class. The class. ¿Y por qué todo cabeza, güey? So this actually looks like the class syntax, right? Where you have is now a function constructor, all right, which is the initial values that you're gonna pass, and then some of these functions, a set of instructions that you're going to define later on. Holy fuck! Holy moly, bro! All right, okay, good. Good. There are many varied forms that JavaScript takes in JavaScript. We dig into this variation in Appendix A. There are many varied forms that function takes in JavaScript. We dig into this variation in Appendix A. So many function forms. And let's get into this. So many function forms. Give me a second, I'll be right back. Well, and just to finally wrap this up, let's going to read about the appendix here. Where they say, hey, in this appendix, we're going to explore some topic from the main chapter text in a bit more detail. Think of this content as an optional preview of some of the more nuanced detail covered throughout the rest of the book series. Values versus reference. In chapter 2, we introduced the two main types of values, primitive and objects. We didn't discuss yet one key difference between the two, how these values are assigned and passed around. In many languages, a developer can choose between assigning or passing a value as a value itself or as a reference to the value. If in JavaScript, this decision is entirely determined by the kind of values. That surprised a lot of developers from other languages when they start using JavaScript. But it's interesting because since I have exposed to this language for so many years, right? And the only thing that I know is this. This meant not to be the reality of the JavaScript language or the programming language, where programmers can identify when you pass now the when you pass now the value of that. Okay? That's interesting. If you assign or pass a value itself, the value is copy here. For example, this. Here, the your name variable has a separate copy of the Kyle string. Exactly. If you pass now a if you assign or pass a value in it itself, the value is copy. String from the value that's stored in main. Interesting. This is something that's not happening, but I know that this will become more and more and more and more. That's very, very okay. So in any case, here's your number variable. Has a separate copy of the Kyle string from the value that's stored in my name. That's because the value is a primitive, and a primitive values are always assigned and passed as values copies. So primitive values are always assigned or passed as values copy. So in other words, here how you can prove that there is two separate values involved. And this is how, exactly. I want to actually test it. How you can actually verify that this is something that is passed by values and reference. Okay. We are. Okay. we all are talking about is this value versus reference, but it's because now the language programming language allow you to now pass that. That's quite mind-blowing here. So programming language allow developers to not only allocate the space in memory that we're going to occupy here, but also is to now decide how you're gonna how a value is assigned and pass around. And for literal values or for values like this, for primitive in objects, this is how the JavaScript language works. So you can specify is how you're gonna pass the value. The values are exactly how you're going to you can specify to the language if you're going to pass a value, if you're going to assign or pass a value as a copy, all right, or as a reference. So because in JavaScript we don't have that, unlike any other, in like C, C++, another language, where you can specify is how you're going to pass now this value or assign this value by the value itself or by a reference. In JavaScript, that is determined by the kind of values. So if you assign a pass value itself, the value is copy. So this is, for example, you say var, so my name here. All right, and I want to sit here. So if I say this, So if I say this, and then I say your name, so the value here, you can is when you assign, so when you assign or pass a value, unlike any other programming language, which you as a programmer can identify and can do this, all right? Here in JavaScript, you cannot. In fact, you can determine how a value is assigned or passed via its values. So for example, here, if you say your name, all right, it is now passed as a copy. So values that are primitive values are assigned as are assigned as values copies, right? So are assigned as values copy. So here is you can prove if this 2-1. So because this, okay, are assigned as values copy. So if for some reason then I rename this, okay, to say or to say this, right? And then you look at your name is this. So the values are passed by copy, are passed or assigned as a copy when you use a primitive, whether it's a string, a boolean, number, null, undefined, or a symbol or big int. Exactly. So see how your name wasn't affected by the reassignment of my name. Exactly. It wasn't affected by the reassignment of my name to Arturo, and that's because each variable holds its own copy of the value. So by contrast, reference are the idea that two or more variables are pointing to the same value, okay, to the same space in memory or to the same value. Exactly. It's the idea that one or more variables are pointing to the same value, the same objects, such that modifying this share value will be reflected by access via any of those references. In JavaScript, only objects values, which is array, object, function, so anything that is an object value is treated as a reference. But again, is the value here? Is the value? So values are passed. If this is a primitive, values are passed by copies, but this is an object. The value will be now a pointer to when you assign or pass to that, it will now be a pointer to that value. So if that value change, it will change those containers that are using that as a reference. So a good example of this is if we have, well, my address here, and let's say this is the street, and then you have now the city, Cava, and you have the state, Bea, right, La Valle, 2044. Okay, so if you do have this, and then you somehow you say, hey, this is a new address, or your address is now going to be assigned by my address here, okay? So when you assign or pass a value, if this is an object, it's gonna be passed as a reference. In other words, the object value, any variables that are assigned to that are reference to that. So for example, if you say console log here of your address, and then you somehow now modify that, you modify is in my address, and say, hey, the city here, the street now changed to Moldes 2556, and then I look at this containers, any containers or any variables that are assigned to that value. Interesting. Any variables that are assigned to that value are gonna point to that data. Are gonna point to that data. And if that data change, well, for example, your address, and if that data change, all of that will change. Because the value assignment to my address is an object, it is held assigned by reference, and thus the assignment to your address variable is a copy of the reference, not the object value itself. This is why updating value is a copy of the reference. Exactly, it's a copy of the reference, as you can see here. It's a copy of the reference. That's why the update value assigned to my address.street is reflected when we access your address.street. My address and your address have copies of the reference to the single share object. So an update that one is updated to both. Again, JavaScript choose the value copy versus reference copy behavior based on the value type, and primitives are held by value. Objects are held by reference. There is no way to override this in JavaScript in either direction. So, but in other languages, you can specify how you're gonna pass this data. Is this data gonna be passed as a copy, or I'm gonna pass it, which is the actual copy of the value, or a reference to this, or a reference in memory. Recall these snippets from the function section in chapter 2. For example, this, right? So the function expression here is refers to as an anonymous function expression. Exactly. Because we don't have put any name to this. See, it has no name identifier between the function keyword between the function keyword and the parentheses parameter list. This point confused many JavaScript developers because as EXs, JavaScript performs a name inference on an anonymous functions. This point confused many JavaScript developers because as EX6, JavaScript perform a name inference on an anonymous functions. The name property of a function. So for example, if you do something like this, JavaScript. So for example, if you do things like this. So if you do things like var awesome function, okay, and then when I want to assign a set of instruction here, say call things, right? And then return something. 42. Yeah. Magic numbers, please don't return. This is an awesome function, right? However, if you inspect instead of this, is inheriting the name of that function, and the association that happened here is this one. And again, the association between the identifier, which is, let's go back a little bit, please, to this. The association here. So, for example, here, the association between the identifier, the function is an expression that is assigned to a variable awesome function. So the difference from function declaration of form is not associated with its identifier until the statement during runtime. So this association is performed at runtime. The association to the name, which is the association of the variable, that's right, that makes things. So this evaluation is so the association between the function and the association and the identifier happens at runtime. For example, like this. This function expression is a name function expression. It's a name function expression. Since the identifier some name is directly associated. It's a name function expression. It's directly associated with the function expression at compile time. The association with the okay. So what happened when, before you actually read that, okay, some name, I think unexpected identifier, because it is function. There you go. So if I do this awesome function dot name, holy hell. But the association here, holy French toast. Okay, for functions expressions, for anonymous function expression, the identifying or the association happens at runtime. Where for function name expressions, the association also happens at runtime, but with that name. Since the identifier some name is directly associated with the function expression at compile time, the association with the identifier awesome function still doesn't happen until runtime. Exactly. Because this is now an expression, and this expression happens at execution time. At the time of that statement, those two identifiers don't have to match. So those two identifiers don't have to match. Sometimes it makes sense to have them be different. Other times it is better to have them the same. Notice also that the explicit function name, the identifier some name, takes precedence when assigning a name for the name property. Should function expressions be names or anonymous? Opinions vary widely on this. Most developers tend to be unconcerned with using anonymous function. They're shorter and questionably more common in a broad spheres of JavaScript code over there. In my opinion, if a function exists in your program, it has a purpose. Otherwise, take it out. And if it hasn't a purpose, It has a natural name that describes a purpose. If a function has a name, you, the co-author, should describe the name in the code so that the reader does not have to infer that name from the reading and mentally executing the function source code. Even trivial functions like function body like this has to be read to infer a name like double or multiply by 2. That brief extra mental work is unnecessary when you could just take a second to name a function double or multiply by 2. So this small because it is all about, here is the readability here in terms of the computation. If the problem is computation, it makes much sense to describe what this thing is doing. So that brief extra mental model is unnecessary when you could just take a second to name the function double or multiply by 2 once, saving the reader that repetitive mental work every time it is read in the future. There are, regrettably, in some aspect, many other function definitions formed in JavaScript. As of early 2020, maybe more in the future, here are some more declaration forms. Now you have other ways to declare that. Generator function declarations, async functions declaration, async function, exactly. Generator functions, async functions declarations, async generator functions declaration, and export functions declaration. And here are some more of the many function expression form. You can have immediately invoked function expressions, asynchronous immediately invoked function expressions, and arrow function expressions. Exactly. Hey, this is an identifier that can have the value of 42, or that can now multiply by 2, or this. Exactly. So it is quite hard to read, and I get it. I mean, it requires it requires it requires the author to go into this and read that. But luckily for us, now we have is these large language models where we can now build stuff on top of that. Async var g is equal to await and do something async. Return g times 2 and some operations. Keep in mind that arrow function expressions are syntactically anonymous. Exactly. So keep in mind that arrow function expressions are syntactically meaning the syntax doesn't provide a way to provide a direct name identifier for the function. So for example, like this. The function expression may get an infer name, but only if it is one of the assignment form, not in the more common form of being passed as a function called argument, as in the last line of the snippet. Since I don't think anonymous functions are a good idea to use frequently in your programs, I am not a fan of using is the arrow function form. These kind of functions actually have a specific purpose, handling this keyword lexically. So the arrow function is for those functions you want to now handle is the value of this lexically. Alright? Where it matters where it was written, not when it was called. But that doesn't mean we should use it for every function we write. Use the most appropriate tool for each job. Functions can also be specified in class definition and object literal definitions. They are typically referred to as methods. When in these forms, though in JavaScript this term doesn't have much observable difference over functions. Functions can also be specified in the class definition. an object literal definition. They are typically referred to as method, when in this form, though is JavaScript because this is now the object in deprogramming. This is a method. Though in JavaScript this term doesn't have much observable difference over functions because they actually behave the same. So all of this is similar to describing an object with their functions, and functions are values. Holy crap, exactly. So this is an anonymous function expression that is assigned to the old school here. Phew, there is a lot of different ways to define function. There is no simple shortcut path here. Yeah, there is no simple shortcut path here. You just have to build familiarity with all the function form so you can recognize them in existing code and using appropriately. In the code you write, study them closely and practice. Understanding. It's understanding. It's understanding. It's just understanding. Coercive conditional comparison. Yes, that section name is quite a mouthful, but what we are talking about conditional expressions needing to perform coercion-oriented comparison to make their decisions. Oh, this is the coercion. Prototypal classes and things like that. So, go back to this. And here we are in comparison. But I do think I'm gonna leave this. Yeah, I just want to read this. Okay. Yeah, I just want to read this. Let's get read this. Just briefly here. Comparison. Making decisions in programs requires comparing values that determine their identity in relationship to each other. JavaScript has several mechanisms to enable value comparison, so let's take a closer look at them. Equality. The most common comparison in JavaScript are then is this, is the same value of this, so equivalence. For ergonomics and historical reasons, the meaning is more complicated than the obvious exact identity, sort of matching. Sometimes an equality comparison intends exact matching, but other times the desired comparison is a bit broader, allowing closely similar or interchangeable matching. In other words, we must be aware of the nuanced difference between an equality comparison and an equivalence comparison. If you spend any time working with and reading about JavaScript, you have certainly seen the so-called triple equals: equality and equivalence. Equality and equivalence. So this equivalence comparison, it means in terms of its shape, and equality it means in terms of shapes, and equivalence it means in terms of values. In other words, we must be aware of that, the desired comparison. Sometimes an equality comparison intends exact matching. Exactly. Hey, this is the exact matching. But other times the desired comparison is a bit broader, allowing closely similar to interchangeable matching. So in other words, equality comparison is exact matching, and equivalent is similar. If you spend any time working with and reading about JavaScript, you've certainly seen the so-called triple equal operator, also described as a strict equality operator. That seems rather straightforward, right? Surely, strict means strict as in narrow and exact, and not exactly. Yes, most value participate in the triple equalities. Okay, so yes, most value participating in triple equality comparison will fit the exact same intuition. Consider some example. Hey, is this the exact matching? It will some of them, because not all of them, right? So if this exact matching, this is true. The same for strings, the same for undefined, for boolean, for string and numbers, for string, okay, where they are deferred here. The true one, true is equal to 1, exactly, in triple equal. And there's some nuance here. Another way triple equality comparison is often described is checking both the value and the type. In several of the examples we have logged so far, like 42 and 42, and the type of both values, number and string, does not seem to be distinguishing factor. There is more to it than that. Though all value comparison in JavaScript consider the type of the value being compared, not just the triple equality operator. Specifically, disallowing any sort of type conversion, aka coercion, in this comparison, whether other JavaScript comparison do allow coercion. But the triple operator does have some nuance to it. In fact, many JavaScript developers gloss over to their detriment. The triple operator is designed to lie in two cases of special values, nan and minus 0. Exactly. So there is, even though, some nuance here with the triple operator. For example, if -0 or not represent a number, right? Where, yeah, in the case of not an m, the operator lie says that the occurrence of nan is not equal to another nan. Exactly. And in the case of -0, yes, this is a real distinct value that you can use intentionally in your programs to differentiate, for example, movement. The operator lies and say it is equal to regular 0 value. Since the line about such comparisons can be bothersome, it is best to avoid using the triple equal for them. For nan comparison, use the number.isNan utility, which does not lie. And for 0, -0 comparison, use the object.is utility, which also does not lie, as it is. Can also be used for object non-lying nan check, if you prefer. Humorously, you could think of object is as the quadruple equals, the really strict comparisons. And there are deeper historical and technical reasons for this lies, but that doesn't change the fact that the triple equality is not actually strictly exactly equal comparison in the strictest sense. The story gets even more complicated when we consider comparison of object values non-primitive. Okay, exactly. The story gets even more complicated when we consider comparison not only of primitive but also of object values. Like this. Whether if this is a comparison like this, or a function, or an object, or an array, it may seem reasonable to assume that an equality check considers the nature of or contents of the value. After all, 42 is triple equal to 42 in terms of its string, in terms of its type and value. Consider the actual 42 value and comparison. But when it comes to objects, a content-aware comparison is generally referenced to as a structural equality. JavaScript does not define the triple equal as a structural equality for object values. Instead, triple equal use identity equality for object value. What in the F is a structural equality and identity equality? In all JavaScript, all object values are held by reference. So it means that by JavaScript does not define triple equal as a structural equality for object value. Instead of use as identity equality. Hey, they are the same to itself. Oh. Identity equality. Hey, you are yourself. Here this is where we get into the philosophical aspect of this is so it's performing is an identity equality. And remember, equality and equivalence. Equality, it means that it is strict in the same shape as the mentioned here. It is exact matching, and it is exact matching is by it is identity. You are the one who you are. So in JavaScript, all objects are held by reference. Exactly. Which is each one of those objects when you assign or when you pass that, all right, when you assign or when you pass that are held by reference. And because this comparison is not based on its context, it's based on its identity. In other words, based on if this value it is the same in terms of it itself as this, and by itself we can say, hey, in terms of so they are now the same space in memory. And to our current discussion are compared by reference identity equality. Consider this. Var x 1, 2, and 3 assignment is by reference copy. So G reference the same array as x. Exactly. Assignment is by reference copy. So G reference the same array of x, not another copy of it. So exactly. So here, because the assignment is based on the value that have x and the value that hold is not a primitive, is an object, it now G holds a reference to this value. So if this value change or is mutated, it also the token, the reference as well, because they're pointing to that. So it doesn't mean that so G, because they have the same reference. Exactly, it's because they have the same reference. Okay. In this snippet, x triple x, G triple x is true because both variables holds a reference to the same initial array. But the triple here, 1, 2, 3, comparison both fall because G and x respectively are being compared to new different arrays. 1, 2, 3. The array structure and context don't matter in this comparison. Only the reference identity. Hey, what is the value of this and the value of this, right? And when you inspect that, you say, hey, the value of this is assigned to x. And what is the value of x? Well, the value of x now is this, an object. And because it is an object, they are pointing to the same. It's by reference. So JavaScript does not provide a mechanism for structural equality comparison of object values, only for reference. Only reference identity comparison. To do structural equality comparison, you will need to implement the check yourself. Be aware it is more complicated than you will assume. For example, you might just determine if two function reference are structurally equivalent. Even stringify to compare their source code text will take into account things like closure. JavaScript doesn't provide structural equality comparison because it is almost intractable to handle all the corner cases. Mhm. Intractable. Intractable. Hmm. Very difficult or impossible. Intractable. Coercive comparison. Coercion means a value of one type being converted to its respective representation in another type to whatever extent possible. As well as we'll discuss in chapter 4, coercion is a core pillar of the JavaScript language, not some optimal features that can reasonably be avoided. Oh, because here we look at the comparison. Mm-hmm. Equalish, okay, via is uh, strict equality, okay, or content equality, and the other is equality by reference. Or reference identity. And now we're looking at a coercive comparison. Coercive comparison. Okay, which means is the type conversion, exactly. Coercive comparison. So coercion means a value of one type being converted to its respective representation in another type to whatever extent possible. As we'll discuss in chapter 4, coercion is a core pillar of the JavaScript language, not some optimal feature that can reasonably be avoided. But when a coercion meets comparison operators like equality, confusion, and frustration unfortunately crow up more often than not. Few JavaScript features draw more ear in the broader JavaScript community than the double equal operator, generally referred as the loose equality operator. The majority of all of this writing and public discourse on GS condemn this operator as poorly designed and dangerous, bug ridden when used in JavaScript program. Even the creator of the language himself, Brendan H., has lamented how it was designed as a big mistake. From what I can tell, most of this frustration comes from a pretty short list of confusion corner cases. But a deeper problem it is extremely widespread misconception that it performs its comparisons without considering the type of its compared value. The double operator performs an equality comparison similar to how the triple performed it. In fact, both operations considers the type of the value being compared, and if the comparison is between the same value type, both exactly, and if the comparison between the same value type, both the double equal and the triple equal do exactly the same thing, no different whatsoever. If the value type being compared are different, the double equals differ from the triple equal in that it allows coercion before the comparison. In that it allows coercion before the comparison. In other words, they both want to compare values of like types, but double equal allow type conversion first, and once the type has been converted to the same on both sides, then the double does the same thing as the triple equality instead of loosely equality. The double operators show the described as coercive equality. It's because exactly when you read about the spec, especially the abstract operation, mm-hmm, especially the abstract operation. You can see what is doing. If this is one of them is null or one of them is undefined, so if one of them is null and the other is undefined, it's gonna return true because again it's doing this true nature. It's coercing here. Okay, it's coercing. So if one of them is null or undefined, it's gonna return is true. If one of them is a string and the other is a number, it's gonna coerce the string into number. If I recall that right. So it's gonna coerce this string into a number, and then do the comparison in the same time. So because this value, when it is coerced to a number, it is as 0. That's why you have this as true. Exactly. And not to mention is all of this and other funny behaviors like this. Which tell you that this is true. And here is when things started to get more and more and more and more mind-bending, mind-blowing. In both comparison, the value types are different. So the double cause the non-number values 42 and the true to be converted to a numbers. Exactly. So if one of them is a string, I'm gonna convert it into a number and then do the comparison here. And for example, in this case, because you are comparing is objects, is doing this referential comparison, where it's gonna tell you that hey, this is false, no matter if you treat this as it is, because when it comes to this value type, it's doing this reference comparison, right? Hey, do they have the same reference? Okay, no, all right, no problem. Okay. But when we do things like this and like so what it's doing is that, well, I'm going to now is first evaluating is this, because what you're doing here, you're saying is like this, it's like doing this coercion. That's what happened. This is exactly what you're doing is this. So if for some reason now you are coerce one of those values, this string, this empty array, is coerced to an empty string, okay, where if the other operand is now an object, it's going to attempt to coerce that into a primitive, okay, which is into a string usually, and then into a false. So is this. And this is why you have things like this. But this is what happened is behind the scenes here. But the point of this is that I will be, again, it is good to understand what this double equal is, as well to say, no, we're not gonna use this. We are not definitely going to that path, into that route. Not at all, my friend. Not at all. Not at all. I would like to, no, but not at all. Not at all. Not at all. Not at all. Just be aware of this nature of the double equal, that it prefer primitive numeric operations comparison. help you to avoid most of the troublesome corner cases, such as staying away from gotchas like empty arrays, which are equal to 0, or zeros that are equal to false, alright? Because it's doing this coercing, right? You might be thinking, oh well, I just always avoid any coercive equality comparison using triple equal instead to avoid the corner cases. And sorry, that's not quite as likely as you will hope. That there is a pretty good chance that you will use relational comparisons operators like this. Mm-hmm. This kind of operators, right? Let's say like greater or less equal less or greater than, and this one, just like the double operator, these operators will perform as if they are strict if the type being relationally comparing already match, but they are allowed coercion first, generally to numbers, if the types differs. Mm-hmm. Interesting. So if the type is different, like this, so consider as this. You have now this collection, all right, and you want to iterate in it. So what I'm saying is that, hey, I want to start from the index 1, and then now, as long as, okay, okay. Okay, look at this. Because you are doing is this kind of stuff. I want to now evaluating is this and this another one, which means is that if the index is less than the array length, okay, and the value of that position is less than 500, okay, I will stop there. That's my stopping condition. And then I want to increment this. So then what it's gonna do is this kind of thing is obfuscating. I don't think this is something that you should do here. You can't do that. You shouldn't definitely not that. You know how many time I spent here? It was not that much, but I prefer to go into things that are really more straightforward, that are more relevant to. So the I array length comparison is safe from coercion because both of them are now numbers. But this is not safe because this value, which is now a string, is gonna try to coerce that. So again, this not only for comparison, not only for equality but also for comparison, is doing this operation here. Is doing these operations here. So it's going to coerce this, all right? It's going to coerce. Hey, this is a string. No, I prefer is numbers. So I'm going to coerce that into a string, a number, all right? And well, despite that this is not safe, it will also evaluate this, and what by the time that it reaches the 0, it's going to see this, evaluate this statement and say, hey, yes, all right, we can proceed. 1 is less than the 0, 1, 2, 3. All right. So yeah, it's 4. It's 3. Actually, this is now 4, right? And then you say, hey, if the current value of the position is less than 500, well, I am coercing this into a number, which is transforming this into 1, and 1 is less than 500, yes. Okay, for the first iteration, good. So, but the second iteration, we're gonna ask the same. Now, this is 2 less than 4, great. And, it's 1. And 10 less than 500, so good. Now the next iteration, you say, hey, this is now 2. It's in this position. It's less than 4. Yes, it is. And then it say, hey, 100 is less than 500. Yes, it is. All right. Next iteration. Let's go here and check this one. If the length is less than the array length, which is 0, 1, 2, 3. Yes, it is. Okay, good. But if the current value of that position is less than 500, no, so I'm gonna not proceed to the next one, and I'm gonna follow this instruction here. You're gonna stop there. And 1000 is less than 500. Since that for 1 is false, the loop stops after a third iteration. These relational operations typically use numeric comparison, except in the case where both values being compared are already string. In this case, they use alphabetic dictionary-like comparison of the string. True, watch out. And there is no way to get these relational operators to avoid coercion other than just never use mismatch type in the comparison. That's perhaps admittable as a goal, but it's still pretty likely you are going to run into a case where the type may differ. The wiser approach is not to avoid coercion comparisons, but to embrace and learn the ins and outs, which is something that can happen. It's part of the language. Coercive comparison crops up in another place in JavaScript, such as conditional, if, etc., which we'll revisit in Appendix A. Coercive conditional comparison. And if we go to the coercive conditional comparison, which is this, yes, that section name is quite a mouthful. It's quite verbose. But what are we talking about? We're talking about conditional expression needing to perform coercion-oriented comparison to make their decision. If n, question mark, this one, ternary statements as well as the test clause, if and ternary statements as well as the test clause in while and for loops all perform an implicit value comparison. But what sort? It is strict or coercive? Both, actually. But what sort? So consider as this. So here if and ternary, if and ternary statements as well as the test clause in while and for loops all perform an implicit value comparison. But what sort? It is strict or coercive? Both, actually. So in this case, it say, hey, it will run because it will coerce it into a boolean. For example, like this. It is evaluating an expression and coerce that into a boolean. This will run, as well as this will run once, and x is equal false. You might think of these conditional expressions like this. X is equal to true will return. And so it's doing this. So if, while, do while, but most of the time we don't use do while, but if, while, and if, while, and this ternary operator. In this specific case, the value of x being 1, that mental model works, but it's not accurate. More broadly, consider this. So it will run, because what it's doing is to say, hey, if this is a value here, so not only that it's checking is strict and coercive. So not only that this is coercive, but also it's strict and coercive here. So it means that both of them exactly won't run. So what if statement actually do? This is more accurate. Is coercing that value to a boolean and then evaluating to true. So which is the same as this. Since boolean functions always return a type of boolean, the double operator and the triple operator in this snippet is irrelevant. They both do the same thing, but the important part is to see that before the comparison, a coercion occurs from whatever type x currently is to boolean. You just can't get away from coercion in JavaScript comparison. Buckle down and learn them. So it's interesting. So if it's doing a boolean coercion, exclusively a boolean coercion, whereas while does not coercion here. They don't do coercion, but they do coercion and strictness. But for example, this. So a boolean value, by the way, a boolean value here, okay? So a boolean value is it is better to go through the falsy values, because anything that is not a falsy value is a truthy value. So in other words, if you have this particular code and then you say something like this in a while, console log, let's say if, and then you do this console log of while, because now the if and the if is gonna do this boolean coercion, but the while is the while doing a boolean coercion. Let's find out. Oh, fucking course. Oh shit! No. Wait. Well, I already crashed that shit. Okay, we got it. Yeah. And it's mind blowing. It is mind blowing. So it's doing both, motherfucker. Oh shit! So while and if are doing both. So they are coercing. So they are coercing that. So that's what you need to have. That's when you need to be careful of that. So it is important at the end of the day to understand that coercion is something that is gonna be with you. It's something that is gonna be with you. Deal with that, bro. Holy moly. Deal with that. And then we look now at how we organize in JavaScript. And I do think this is quite interesting. I'm just gonna continue to read this now that we are already here. And we're back. Give me a second. I'll be right back. And we're back. And let's gonna do a quick read of the how do we organize in JavaScript, shall we? So the two major patterns for organizing code, data, and its behavior are used broadly across JavaScript ecosystem. Classes and models. Interesting. Functions is not a way to organize it's not a way to organize the code. Classes and models. So anytime that you want to cooperate or communicate to others, when the problem refers to that, so now classes, this object-oriented programming is a way to collaborate with them. And when you need to compute, that's different. So two major patterns for organizing code, data, and behavior are used broadly across the JavaScript ecosystem, classes and models. So these patterns are not mutually exclusive. Many programs can and do use both. Other programs will stick with just one pattern or even neither. In some respects, these patterns are very different, but interesting in other ways. They're just different sides of the same coin. Being proficient in JavaScript requires understanding both patterns where they are appropriate and not. This is why I want to dive deep here. So the term object-oriented, class-oriented, and classes are all very loaded, full of details and nuance. They are not universal in definition. We will use a common or somewhat traditional definition here, and the most likely familiar to those with background in object-oriented programming language like C++ and Java. A class in a program is a definition of a type of custom data structures that include both data and behaviors that operate on that data. So this operation of the data, these operations of the data via its behaviors, exactly this operation of data, these operations that we can do on data to create via by modifying or via its behaviors, or aka their methods, okay, is because we define is a custom data structure, okay, of a type. All right, so we create a custom data structure in our programs, and classes define how such a data structure works. But classes are not themselves concrete values. Exactly. Again, this is how we organize our code, but they are not concrete values. They're just a class in a program is a definition of a type of custom data structure that include both data and behaviors. So to get concrete value that you can use in the program, a class must be instantiated with the new keyword, one one or more times. So this is now a type, it's a definition of a type of custom data structure. Okay, it's a definition of the type of custom data structures that include is the data and it is behavior. But again, this is a way of how you can organize this. Okay, it's a definition of a type. Okay, it's a definition of a type of values of custom data structures, right? In this case, a custom data structure that includes the data as well as its behaviors here. And class notebooks as well as this, the construction and add page and prints and so on and so forth. But again, this is a definition of the type of a custom data structure that includes the data, the value, all right, as well as its behaviors here. Page.print. And when you create now a new book, map node.add pages, you do this, or map nodes add pages, add page trigonometry, seeing concept, blah blah blah, and then I want you to print that. So in this page class, this custom data structure, because it all starts with this custom data structure, in the page class, the data is a string of text stored in a this.text member property. The behavior is a print and method that dumps the text to the console. For the notebook class, the data is an array of page instance. The behavior is add page, a method that instantiates new page. Okay, for the notebook class, the data is an array of pages, of page instances. The behavior is add page, a method that instantiates new pages, and adds them to the list. For example, in the added, exactly, and added to the list. As well as the print, which prints out all the page in the notebook, right? So it's a page. I'm gonna call that page instance, all right, which is quite fucked up. Page.print, and as it is. All right, so let page of this page to print that out. Okay. So the statement math nodes equal to new notebook, create an instance of the notebook class, and page is equal to new page text is where instances of the page class are created. So the statement math node, new book, new notebook, creates an instance of the notebook class of this data structure, and page equal new page text, and page, okay, and that, and page new page text, and page new page text is where instances of the page class are created. Exactly. So again, this is a way of how you can communicate this, because they have a relationship here. Behaviors method can only be called on instance not the class themselves, such as math notes add page and page.print, but they can be called only on the instance. Exactly. The class mechanism allow packaging data, text, and pages to be organized together with their behaviors. Add page and print. The same program could have been built without any class definition, but it would likely have been much less organized, harder to read and reason about, and more susceptible to bugs and subpair maintenance. Because it's this here, subpair maintenance and reason, harder to read and reason about. Class inheritance. Another aspect inherit to the traditional class-oriented design through a bit less commonly uses in JavaScript is inheritance and polymorphism, a function that can have output different something like that, I think it is polymorphism. So consider this: class publication, the construction, and exactly the so here we are defining is the custom data, and it wants to do this. Here we're defining is a custom data structure of this type that it contains is now the data and it is functionality. All right. And great thing is that this is something that behaves somewhat similar as a function object here, or a function inside of an object, right? So this pretty much behaves the same as it is in JavaScript. Okay. So here what we're saying is that by the time that we create that, we're going to create a new instance with this data, custom data. The title, the author, and the pub date, right? And that data will have not a print. And this method, what it's going to do is just to have access to this data and print that out. Pretty much so. So this publication class defines a set of common behaviors that any publication might need. Let's now consider more specific type of publications like book and blog posts. So you have now class book extended publications. All right. So you have now a book where you now call the superclass with all of this details exactly. And you're going to add some additional custom data to this, as well as for this. And the other is the blog post. You're going to get that somewhat similar, right? But you add a new one, right? As well as some of their methods here. Both book and blog posts use the extend clause to extend the general definition of a publication to include additional behaviors. The super call is in each constructor delegates to the parent publication class constructor for initialization work. And then they do more specific thing according to their respective publications type, aka the subclass or the child class. So now consider using this child class. So here you're creating a new instance with this value here as an object that we're passing here. And then we say, hey, I want to print this. And then you print this. And then you create now is a blog post, right? For against let. With this. Exactly. But now instead of an object, okay, you do is in fact pass this as parameters, as a comma separate value. Okay. And then you print that and you get that. Notice that both child class instances have print method, which was an override of the inherit print. But as you can see here, exactly, it was overridden by that title. It was overridden by that. The fact that both the inherit overridden method can have the same name and coexist, it is called polymorphism. Inheriting is a powerful tool for organizing data behavior in a separate logical unit classes, but allowing the child class to cooperate with the parent by accessing using its behaviors and data. And then you have now models here. The model pattern has essentially the same goal as the class pattern, which is to group data and data behaviors together into a logical units, also like classes. Models can be include or access the data and behaviors of other models for cooperation's sake. So when you do have a problem of cooperation or communication, then you use a model here. But models have some important difference from classes. Most notably, the syntax is entirely different. Classic ES model. EX is added a sub-method class because of a model in this form is just a function, and calling it produce. So I will have to go because I need to go and see the doc. So that'll be all for this video. Take care. Bye bye.